So I've spent the last several months going really deep on agentic large language models and what kind of use cases they're useful for, what kind of applications they're useful for. Long story short, I ended up making my own declarative agent framework, and I'm not going to describe what that means. I'm just going to demo it, and I think you'll be able to see some of the reason why this is going to be actually pretty useful, or a useful approach to agentic large language models. So I'm in Cursor AI right now, and what I'm doing is I'm prompting GPT-5 to create a new agent under the examples directory that takes a startup idea from the user, myself, and crafts a plan to validate the idea using the lean startup philosophy. So what this is going to do, the final output of this, is it's going to output a runnable agentic large language model that, again, I can run, but there will be no code involved. It'll be completely declarative. And so what it's actually going to output is a YAML file. So this is a similar pattern in technology history as like going from jQuery to React and Virtual DOM, where you're being more declarative about what you want the final output to be and abstracting away the delta to get to that final output. Same thing for something like Terraform and infrastructure as code. That's a very declarative way of specifying infrastructure. Taking those same ideas, that's this declarative way of specifying what you want, I'm applying it here to agentic large language models. And what this will output at the very end here is more or less a YAML file that specifies some basic properties about the agent, how it works, what the prompt is, what kind of input it expects, and what kind of output it should deliver. And I have some more bells and whistles built on top of that. So let's let this go here. Okay, so this did create an agent. It is located under not basic examples, but standalone, and it called it a lean startup validation agent. You can see, as I said, this is its output, and this is a runnable agent. It's got a name, it's got a type. So this particular agent will output structured output. So JSON, for example. You can see the prompt here. You're a lean startup advisor. You get a startup idea, produce a concise or action-oriented plan. Here are some requirements. I'm not going to go into this, but what I am going to do is sort of kind of kill it a little bit and make it a little bit dumber, because we're going to use an AI as a judge to improve it. Because this is a Quinn model, the temperature needs to be that, and it specifies the output schema, and I'm just going to assume that's okay, because what I'm going to do next is just run it. So what I'm going to do is run python.env framework.cli. This is under examples, standalone, lean startup. So again, this is how you run the declarative agent, and off it goes. It is actually using a local model, Quinn3 1.7b, so 1.7 billion parameter model, and it has output something. I guess I forgot to give it some input, so let me run this again. So what should be my startup idea? My startup idea should be dinosaur popsicles. Let's say that's my startup idea. So when we run this again, we will see that, okay, it's thinking about it, and it has output a plan about dinosaur popsicles. It's got a validation plan and assumptions, et cetera, et cetera. The whole point of this isn't to teach you the basics of the lean startup, the book, The Lean Startup, but more about how to use this framework to get really interesting results here. So, so the problem statement: addressing the gap in the popsicle market with a unique theme product that aligns with the current consumer trends, et cetera, offers a fun, engaging experience. Okay, so it created an executable large language model. Yes, it outputs to the terminal now, but it takes very minor modifications to get this output to some other interface like a website. Now, what else is interesting here is I've created an evaluation framework as part of this declarative framework, where you can create very simple LLMs as a judge, or AI as a judge. So let's do this. I'm going to say create an eval for this new agent. It should evaluate whether the agent outputs some experiments with measures that are SMART. And this is the acronym SMART, as in specific, measurable, achievable, et cetera, et cetera. It'll know what that means. and let's just have it do that. So similarly, this will create, this time it's going to create just a very small declarative Python file, but it's going to specify a test case and the evaluation criteria. And this is all that is required in order to create an LLM as a judge. So let's watch this. What it's doing right now is it's reverse engineering my framework. I can expedite this process by providing it a lot more useful context than what I've given it, by giving it like rules and instruction files. I've just been lazy and haven't done that yet, so I will get around to that. But yeah, the holdup right now is it's just reverse engineering how this whole thing works. And typically it does a pretty good job of figuring it out. Okay, it has produced the definition for an AI as a judge, which is great. So if we look at this, this file basically only has two pieces. One is the test suite. It's an array of prompts, so an array of user inputs that should be autonomously passed into the agent. In this case, it only has one example, dinosaur popsicles, and then it has a natural language validation criteria that the LLM as a judge is going to use to determine whether this agent should pass, whether it is of sufficient quality. You're just kind of skimming through here: specific, measurable, achievable, relevant, time bound, internally consistent, failure cases fewer than 2 experiments. Sure, that all seems fine. So let's just run this. So here was the command previously to run this. Now what I can do is just specify that I want to run this agent, but pass in an eval flag. So when I run that, what it'll do is feed in that one example, and you can see it fed in the dinosaur popsicles example, and it's going to run the lean startup validation agent first, and then once it's done that, it is then going to pull up a larger model to judge it. And so I do want this to be a larger model because I want the judge to be pretty smart on this. You can see right away it fails this, which is fine. But it says it failed, and here's the judge reasoning. The evaluation criteria requires at least 2 distinct experiments and validation experiments, et cetera, et cetera. Again, for the purposes of this demo, it's not important to really unpack these details, but to see what really this is capable of. So now what I'm going to do is I'm going to reference this in context here. So I'm going to say, let me paste that. So now that it is added as context, I'm going to say, look at why this failed the eval. Then I want you to create a sub agent that is called by this agent and delegate a sub problem to that sub agent. So do this by first specifying an eval for that sub agent, make it pass, then go to the parent agent and modify it to use the sub agent, then modify the parent prompt as needed to make it pass. Always use Gwyn 3 1.7b with temp 0.7 and top P of 0.95, and let's run that. Okay, so that was maybe hard to understand as I was typing it out, but what I basically instructed GPT-5 to do is to notice that this failed and understand why it failed. It has the judge reasoning as context in addition to how the agent is specified as context, so it'll understand why it failed. And then what I basically said is create another agent that this agent uses as a helper to solve a smaller part of the problem, because it is such a small model. This is only a 1.7 billion parameter model, as you can see right up here. So I basically say, go delegate some part of this to another agent, but as part of that delegation, create its own eval and get that thing working well. And then once that's working well, let's return back to this agent that we have on the screen and iterate from there. So you can see what by making this all declarative, what we're doing here is we're allowing this, we're number one, separating code from definitions, which is a good thing to do in and of itself. And by doing that, we're making it simpler and easier for a large language model to semi-autonomously or autonomously iterate on other agents and make them better. It knows all it has to do is specify a declaration, a file, a prompt, a schema, etc. to define the agent. We'll see how orchestration works here in a moment once this kind of kicks off here. But we're also giving it the ability to autonomously create more sub-agents. So basically take a larger problem, break it down to smaller problems, and that translates directly to taking a large agent, breaking it down into smaller agents, and having the large agent, instead of solving one large problem, it now changes its role to becoming an orchestrator of several smaller agents that solve smaller problems. And it's just aggregating all the inputs and outputs to produce a final output. Okay, so it's created a new agent. This one is called the Lean Startup Experiment Generator Agent. And let's just take a peek at this while it's still working. Okay, you generate a set of smart lean up startup experiments from a brief startup idea and action requirements. Generate exactly 3 requirements optimized for the next 14 days. Blah, blah, blah. And output schema. So again, the whole point of this isn't to demonstrate how to think like a lean startup engineer or software professional, but more about how do we take a problem that's too large for one agent and to break that problem up into smaller pieces and delegate to other small agents here. See that it created the eval for it. So let's go take a look at that. So I'm going to keep this and the evals here. Let's take a look at it. So the eval has a similar prompt, but this time the criteria, it says pass only if all the conditions are met, the count and presence. So there needs to be exactly 3 experiments, specific and hypothesis linked, measurable, achievable. Okay, so I see, the SMART acronym is sort of in there already, but ideally what this is doing, if I was kind of in a crunch to kind of show a good demo for a short video, is kind of help guide this along to break the problem up into smaller pieces. And maybe sometime in the future, these large language models will be smart enough to do this completely autonomously. Anyway, it is done, and it looks like it created it but didn't run it. So I need to kind of give it a nudge here. Run the new eval and iterate on the new sub-agent until the eval passes. Then move on to the parent original agent and have it call the sub agent. Refer to examples under another example called deep research. So on that note, I have created an entire deep research application using this style of declarative agents. So while GPT-5 is kind of chewing on that, I suppose I can just quickly take a look at that. So here I've got a deep research example, and this example is fairly complicated. I have one high-level orchestrator agent, and what the high-level orchestrator agent does is basically figure out when to call 3 other high-level agents. One's a clarifier. The clarifier agent's entire job is to get a well-specified research query from the user. There's a researcher, and then there's a summarizer. And then when you unpack this further, yes, there's a clarifier agent that was called by the top level, but it also has its own set of sub-agents, for example, or different sets of tools. So it's got a get input tool, user input tool, and then other agents like a clarification agent and a revision agent that you can see some of those are defined right here. So you can see once I expand all of this, the deep research application, I've created a deep research application that has almost no code. There's some code for getting user input. There's some code for getting the current date time from the system. But outside of that, all of the research, the clarification, the summarization, and all the system 2 techniques that go into making all that go really well is 100% declarative in YAML files. And I think that's I mean, that's kind of cool, right? You don't have to know a lot of code to build an example or an application as complex and nuanced and as effective as a deep research application. So just know that that is sort of an end state that I was working backwards from, and I was able to get to it with this declarative framework. But anyway, looking back over here, I see some passes, so that's got to be a good sign. Let's see where we're at here and if it stops. So it's summarizing agent updates. Let's see. Both show pass. That's great. Added standalone. Okay, so apparently it's done. So let me double check this. So we have the generator agent, we have the validation agent. Both of them have evals. And if I double check the top level agent, the changes that were done here, this says, so the addition was you must delegate the generation of smart experiments to this tool. There's some instructions for using that tool. And for technical reasons, whenever I had a handoff to another agent, I use the LLM as a tool functionality from the underlying code. I won't get into that in this video, but basically here you could see it is referencing the new agent that it created, a description of what that agent does, the fact that it is not just code, it is actually its own agent in and of itself, and the name is called Generate Experiments Tool, which it then references from the prompt, and it instructs that top level agent when and how and why to use that. So let's see if this actually worked. So there is the lean startup generator agent YAML file, and apparently there's an eval, and this should now pass. So let's see if it does. Again, this is the agent running, and then there's a AI as a judge, LLM as a judge, that is now running right now to evaluate it and determine whether it actually does pass based on the output in the top half of that terminal output there. So it looks like it does pass, so that's good. So let's just go for broke here and go back to the original. And instead of saying dinosaur popsicles, let's give it a different startup idea. Let's say a startup that gathers food waste and sells and composts it and sells the compost material. So I'm just going to give it something different, something new, and see if it can appropriately delegate work to the sub-agent and produce something pretty useful here. Okay, it produced a final result, and rather than looking at the smashed version of it down here, I'm going to scroll up a bit because it has a better formatted version up here. There's a validation plan. There are, let's see, it looks like there are 3 experiments. One is a landing page smoke test. Just going through this quickly, build a minimal viable landing page with a pre-order form and testimonials, tested on Instagram. That looks like just like a generic one, so that one's not too impressive. But the next one is problem validation interview, identify pain points in food waste management and willingness to pay for compost services. That is a very good experiment if this were a good startup idea. Conduct 30 interviews. Yeah, that sounds great. Estimated cost. Yeah, this is all good. Pre-order form conversion. Measure willingness to pay for compost material via simplified pre-order process. So yes, this is all very relevant and all very lean startup-like. So this is all very good. The go, pivot, kill criteria is, so for go, all 3 experiments meet success criteria. Obviously that'd be a go, of course. Pivot, at least 2 experiments fail critical metrics, and it specifies those measurements. And the kill is all experiments fail critical measures. Okay, scrappy tactics, use Instagram ads, conduct interviews via Zoom, launch pre-order form. Okay, cool. Timeline, looks like there's a 10-day timeline. That's great. Assets required, Figma, budget time. Okay, so this is, I mean, this seems all very sane, so this is all pretty good. The other thing we can look at while we are kind of evaluating how well this went, let's see, it would be this one. Looks like my tracing got a little bit off here, but in theory, once I get my tracing fixed, we can see here This is the top level agent. It took 20 seconds to run. It had, an input. It had a system prompt, which is what it was above. It has user input, which is what I had typed in, a startup that gathers food waste and composts it and sells it. You can see based on that decision, it had decided to perform a tool call or a function call. And the function call was the generate experiments tool, which is in and of itself another agent. And you could see, the input of that and the output of that and so on. So even tracing is automatically wired up here, which is really great when you have something that's just kind of running autonomously on its own. So getting back to the punchline here, what we have essentially done here is created at first one agent, but ultimately two agents. Those agents have basically zero code. The only code that you can kind of see if you squint at this is there are technically Python files that specify two constants, but there really is no code. This is all declarative, all definitional. These two files right here specify how to determine whether this is working well by using an AI as a judge technique, and the parent level agent knows about the sub agent by a mechanism exposed in this framework. It knows where to find it, and it knows how to call it here. So again, it's really powerful. It's really good for iteration. And like I said, going back to the power statement, you can get really complex applications out of this by iterating in small pieces and getting the smaller agents to work well first, using AI as a judge. Once those smaller agents work well, then take it up a level and get the orchestrating, the next level of agents working well. So anyway, I'm open sourcing this week. I will include this example in the examples directory. So if you want to take a closer look at it, because I went through it very quickly. Yeah, that's all I have to share. Thanks for watching.